In this video, we are going to study that how the frequency can be measured with the help of cathode ray oscilloscope, also known as CRO. So let us start with our topic. We know that in the cathode ray oscilloscope, we are having two inputs, the vertical input and the horizontal input. The vertical input is the input signal which we want to measure or which we want to display on the screen of the CRO. Whereas the horizontal input, it is an internally generated ramp voltage, and when these two inputs are applied to the CRO, we will get an output waveform on the screen of the CRO, which is the plot of an input signal versus time. Now, when two sinusoidal signals they are applied to the two inputs of the CRO, we get some patterns on the screen of the CRO, and these patterns are called the Lissajous patterns. Okay, so whenever two sinusoidal voltages are applied as an input to the CRO, we will get the Lissajous pattern on the display screen of the CRO. Now, these Lissajous patterns, they are used for the measurement of frequency and phase difference between the sinusoidal signals. So, how these Lissajous pattern can be used for the measurement of frequency? Let's see. As we know that CRO is having the two inputs, that is one to the Y plates and second to the X plates. Now here, because on both these Y plates and X plates, we are providing the sinusoidal signals. So on Y plate, we will apply the sinusoidal signal whose frequency we want to measure, and on to the X plates, we will apply a standard sinusoidal signal whose frequency is already known to us. So on the Y plates, we are providing the signal whose frequency we want to measure, and on the X plates, we are providing an accurately calibrated standard variable frequency source, which is providing us a voltage which is having the fixed frequency which is already known to us. Okay. Now, because on X and Y plates we are providing the sinusoidal signal, so the internally generated ramp voltage, or we can say the internal sweep generator, it is switched off. Now for for doing the measurement of frequency, what we will do, we are going to adjust the frequency of this standard variable frequency source. We are going to adjust its frequency such that on the display screen of the CRO, we are getting either a circle or an eclipse. So we can say that the Lissajous pattern which we are getting on the display screen of CRO, it will be either a circle or an ellipse. Because whenever we are obtaining a circle or an ellipse as a Lissajous pattern, it shows that the frequency of the both the signals, both the sinusoidal signals, it is equal. Okay, so the frequency of the standard signal is already known to us. So if we are getting a circle or ellipse, it means that the frequency of the signal is equal to the frequency of the standard signal. Okay, so both of them will be having same frequency. So in this way, the frequency of the signal, it can be measured. So the standard frequency, it is going to be adjusted until we are getting the Lissajous pattern as a circle or an ellipse, indicating that the frequency of both the unknown signal and the standard signal, they are same. Now it may be possible that we are not getting the same frequency. It may be possible that the standard frequency is a multiple or sub multiple of the unknown frequency. So that may also be possible that it may be twice or thrice of the unknown frequency. Now this was the case when we are getting the Lissajous pattern as a circle or a ellipse. Now if what will be the frequency if we are getting a different Lissajous pattern? So in that case, the frequency can be measured. Let us first take an example here. So here we are having the two inputs. On the Y plates, we are applying the signal whose frequency we want to measure, and on the X plates, we are applying the signal whose frequency is already known to us. So here voltage applied to Y plates, which is known as which is represented as EY, and this is the voltage applied to the X plates. Now when these two signals are simultaneously applied as an input to the CRO, we will get a Lissajous pattern here. So when these two signals are applied, the Lissajous pattern which we are obtaining on the CRT screen, this is the CRT screen. You can see that this Lissajous pattern, it is an 8 pattern. This is a 8 pattern which we are getting. So if we are not getting a circle or ellipse, it means that the frequency is different of these two signals. Okay, now here you can see that the signal which is applied on the Y plates, it is having the frequency as 2f, and this is having the frequency f, because here you can see that 1 to 12 numbers, it is completing half cycle, and here 1 to 12 it is completing full cycle. So it is having the frequency twice as the frequency of the standard signal. Okay, so in this case we are getting an output which is an 8 pattern. So in this case, we will get the different Lissajous patterns when the frequency of both the signals are different. Now, how we will get the frequency if we are not getting an ellipse or a circle? The formula for that is so the ratio of frequencies between the signals Fy and Fx, that is the signal on the Y plates and the X plates, is given by the number of times the tangent touches top or bottom divided by the number of times tangent touches either side. So here we were getting the 8 pattern. So if we draw a tangent here, this tangent is going to touch the pattern at 2 points, touches top or bottom. If we draw a tangent on the top side, it is touching the tangent at 2 points, and if we draw a tangent at the bottom side, it is touching the pattern at 2 points. So here we will write Fy upon Fx equals to 2. Now number of times the tangent touches either side. So if this side we draw the tangent, it is touching the pattern at only 1 point. If on this side we draw a tangent, it is going to touch the pattern at only 1 point. So it is 1. So the ratio between Fy and Fx is 2:1. So in the same example, we have studied that here when the frequency of the two signals, that is the frequency of the signal applied on the Y plates, it is twice the frequency of the voltage applied on the X plates, we are getting an 8 pattern. Okay. Similarly, there are different patterns which are obtained and different frequency ratios associated with it. If we see here, we can draw the different patterns like if we are getting this type of pattern on the CRT screen. So if we want to find out the ratio, we are going to draw the tangent. So Fy upon Fx will come out to be, here 3 points are there, so 3, and on the either side it is touching only 1, so this is 3:1. Similarly, if we are having 4 here, so that will be 4:1. Similarly, again if we are having a pattern like so this is touching like this. Here also it is touching at 1 point. If we draw this tilted, so it will be touching at 2 points. Here also 2 points. So we will be getting 1:1 ratio. Okay. So in this way, the frequency ratios can be find out. Now, We can say that Fy upon Fx is equal to the number of horizontal tangencies divided by number of vertical tangencies. Okay. So the frequency of the signal which is applied to the Y plates divided by the frequency of the signal which is applied on the X plates, their ratio will be equal to the number of horizontal tangencies and the number of vertical tangencies. Also, we can write it in the form like number of intersections of the horizontal line with the pattern and number of vertical or number of intersections of the vertical line with the pattern. Okay, so that will be the formula with the help of which we can find out the frequency of an unknown signal which is applied on the Y plates. Now, this formula, if we want to measure the frequency of the signals like now, if we have obtained a pattern like this on the screen of the CRO, and if we are using the same formula that the number of horizontal tangencies divided by the number of vertical tangencies. So, vertical tangencies, if we see, there are 2 points where the vertical tangency is touching the curve, and there are 3 points where it is touching the horizontal tangency. So Fy upon Fx will be Fy, that is horizontal 1, 2, 3 and vertical 1 and 2. So the ratio comes out to be 3:2. But this is wrong. The answer is wrong. So some modifications is done in the rule when we are treating the Lissajous patterns which are having open end in them. Okay, so for such Lissajous pattern, the open end, the part of the Lissajous pattern which is open, it is treated as half tangency, and the closed part it is treated as one, or we can say full tangency. Okay, so if the Lissajous pattern is having an open end or free end, it will be treated as half tangency, and if it is having a closed part, then it will be treated as full tangency. So in this way, the Fy upon Fx, here we will be having 1, 2 and half, so 2 plus 1 by 2, and if we see the vertical tangency, there are 2, so it will be Fy upon Fx equals to, if we see the vertical tangency here, it will be 1. So this is 4 plus 1 by 2, that is 5 by 2. Okay, so we have to take the vertical tangency where we are having the closed end, not over the free end. Okay, and if we are having the open end, then horizontal tangency will be considered as the half tangency. So in this way, the rule will be modified for the cases where we are getting a Lissajous pattern which is having an open end in it. Now there are some restrictions in this measurement of frequencies used with the done with the help of the CRO. The restrictions are So there are two restrictions in this method. First is that the CRO, it should have the bandwidth which is required for these frequencies. Also the ratio of the two frequencies, it should not be such that we are getting a Lissajous pattern which is very complicated. So if the Lissajous pattern is very complicated, the measurement of the frequency, it becomes very difficult. So these are the two restrictions, or we can say two limitations of this method through which we are measuring the frequency with the help of CRO. So I hope that this topic, measurement of frequency using cathode ray oscilloscope, is now clear to you. Thank you.